All right, so let's talk about what we're doing in activity 1-1. So I have here my finished procedure set up. So I have stuck a lens, my lens into some Play-Doh, and I've tried to precisely locate it. And the way that I precisely locate it is by getting off to the side. I've tried to precisely locate so that this line here travels straight down and matches where the 0 is on my ruler. And now I have been moving this in and out. And so I'm not going to move it back and forth because I found a spot where it's in focus. And here's where I say that it is in focus. So when I look at that right there, once my camera adjusts, when I look at that right there, I see an in focus image of those trees outside the window. And a person walking in the background. There she is. So that is where I find an in-focus image of a far-away distant object. So your far-away distant object that you're focusing needs to be, at least 10 meters away, if not farther. Okay, so I don't want to focus in on those bars of the window because those bars of the window aren't far enough away. I'm looking at those trees out far enough away. And so when it's really far away, you can be pretty well assured that the rays that are coming into the lens are entering the lens pretty parallel. And so now I am looking for the position of lens A, and this is where our uncertainty, especially in these at-home labs, is going to become pretty important because I've tried to locate this lens at 0 centimeters, but I can't possibly have done it perfectly. So your uncertainty should absolutely not be the uncertainty that is the limitation of this meter stick, because 0.0 plus or minus 0.1 looks to be a little big to me. So I'm going to go ahead and estimate that my lens is at 0.0 plus or minus 0.2 centimeters, because I would believe that I could have accidentally put it at 0.2 instead of 0, but I don't think that I could have been as far off as 0.3. And I'm going to do the same thing for where the location of the screen is. And I encourage you to stand and sit how I am here so that you can kind of get this thing to be straight up and down and then follow it down onto the meter stick and get a measurement. So what I want you to do for this activity is you're going to do this 5 times. So if we were doing this in lab, I would have every member of your group try to do this themselves at least once. But so this is my first measurement. Now I'm going to pick this up, move it out, and move it in again, and try to re-find the location where there's an in-focus image. And when I find that, then I will read it off of the meter stick again and write down my measurements again on this piece of paper, and I will get 5 of them so that I can have a standard deviation. And so I have the position of the screen, and these will be the numbers that you read straight off of the meter stick, and the distance between the lens and the screen. So if you've placed your lens, kids, can you be quiet please? If you've placed your lens right at 0, then the distance from the lens to the screen will be the same as the position of the screen. But if your lens is at, say, 5 centimeters, then you're going to need to subtract the position from the screen. And remember here, when you're calculating a distance, the distance will be the same as the position, but the uncertainty will not be the same as the position, because this distance is a subtraction of 2 numbers. It's the difference between this line here and that line here. And whenever you subtract 2 numbers, the uncertainties add.